This video is part of the Periodic Trends series, and it will focus on the ionic radius trend. Let's begin by taking a look at cations. Remember, cations have a positive charge that is caused by a loss of electrons. When atoms lose electrons from the electron cloud, they end up being smaller than their neutral parent atom. So if you take a look at this picture, you can see that there's a blue side and a red side. The blue side is the positive side, where atoms, when they become ions, they form positively charged ions. And the elements that are listed on the blue side, notice that they are all metals. Metals are the elements that tend to lose electrons in order to form an ion, to achieve that stable octet, to achieve that stable electron configuration. In this picture, if we take a look at calcium, for example, the blue side is the size of the atomic radius. Calcium, because it's a group 2 metal, in order for it to achieve that stable electron configuration, it will need to lose 2 electrons, forming a positive 2 ion. When it loses its 2 electrons, it now has a smaller radius. So the gray circle here shown, or the gray half circle here shown for calcium, that represents the size of its ionic radius. The numbers, or the measurements for the 2 radii, are also given down below. So the atomic radius for calcium, the neutral atom, it's 197 picometers. It tells you down here in the caption that the radius is shown in picometers. The ionic radius is shown as being 100 picometers. So much smaller than the atomic radius. And it's all because of a loss of electrons. Now let's take a look at the anions. The anions are depicted on the right side. Remember, for an atom to form an anion, there needs to be a gain of electrons. When electrons are added to the electron cloud, the cloud becomes larger. So if we take an element like phosphorus, remember, is a nonmetal, so this right side here, these are all nonmetals. Nonmetals tend to gain electrons to attain that stable electron configuration, the way a noble gas has a stable octet. So when we're looking at phosphorus, for example, in red, this shows the atomic radius for phosphorus, the neutral atom. And in gray, we have the ionic radius. So when phosphorus, it's a group 15 element, or group 5A, the groups are shown here. When phosphorus forms an ion, it tends to gain 3 electrons to achieve that stable octet. So when it gains 3 ions, its ionic radius goes from 110, which is the atomic radius, picometers, to 212. So you can see it grows in size because the electron cloud is being added to. You're adding 3 electrons to the electron cloud, so now it's 212 picometers. So anions tend to be larger than their parent atom or their neutral atom because you're adding electrons to the outer energy level, to the electron cloud, and that addition of more negative particles causes added electron repulsion between the electrons, causing them to move farther apart. They're moving farther apart, increasing the size of the ion. So here we have another picture showing us the cations on the left and the anions on the right. Notice what happens to each group as we move down. Hopefully you can see the size of the radius increases. And the reason why that happens is because the number of energy levels is increasing, just like it increases with the atomic radius. The same thing is true for the ionic radius. Now let's take a look at what happens when we move across a period. So let's take a look at the cations first. Let's use the elements in period 5, shown here, as an example. So notice how as we move to the right, the ionic radius shrinks. So the ions for the cations, they're in red. And the parent atoms or the neutral atoms are in brown. So this part right here, this outline, this is the atom. The central part right here in red, the red dot in the middle, that's the ion. You can see the atom has a radius of 244 picometers versus the ion is 148 picometers. If we look at indium on the end, indium also has a larger neutral atom compared to its positively charged ion. So the trend for elements going across a period is that the ions get smaller. Let's see if that holds true for the nonmetals. For the anions, the blue outline shown here is the ion, the selenium -2 ion. The brown circle in the middle, that represents the radius of the neutral atom. So as we move across a period, you can see the size of the neutral atom, which is 117. It's still shrinking. It's still getting smaller as we move to the right. The size of the ion, which is 198 picometers, is also shrinking as we go to the right. Remember, we have more protons added to the nucleus as we move right. And because of the greater effective nuclear charge, the greater positive charge in that nucleus, there's a greater attractive force pulling in those outer electrons closer to the nucleus, shrinking the size of both the atomic and the ionic radius. So to sum up, the ionic radius decreases when we go across a period due to the increase in the nuclear charge across the period. I prefer to remember increasing trends though. So you could say the ionic radius increases when you go down a group and when you go to the left. Let's take a look and see if we can apply our knowledge to these examples. So let's find these ions on the periodic table. F negative, that's fluorine, the fluorine ion, and chlorine negative is the chlorine ion. And we're looking for which one is the smallest amongst these two. So remember, ionic radius increases in the same way that atomic radius increases, moving left and down. So we're looking for the smallest though. So fluorine, because it has fewer energy levels, its nucleus is closer to the outer electrons, exerting a greater attractive force in pulling them in closer to it. Next, let's look at oxygen versus nitrogen. So here's oxygen in yellow, and here's nitrogen. They're both in the same period. So oxygen -2, when oxygen forms an ion, it's going to gain 2 electrons. So let's talk about what that looks like. Oxygen has 8 protons. The neutral atom of oxygen also has 8 electrons. But because we have a -2 charge here, that means oxygen, the ion, has gained 2 electrons. So now oxygen has 10 electrons. Let's compare that to nitrogen. Nitrogen has an atomic number of 7, so that means it has 7 protons. And because we're gaining 3 electrons, instead of 7 electrons, nitrogen now has 10 electrons. So notice how they both have the same number of electrons in their electron cloud. For that reason, we can't use the electrons to determine which one is smaller or larger in size. We need to look at the effective nuclear charge, which has to do with the number of protons present. So protons then become the determining factor. The one with more protons will exert a greater attractive force on the outer electrons, pulling them in closer to it, reducing the size of the ion. So oxygen is the answer here in terms of which one has a smaller radius. Finally, we're comparing a neutral atom to its ion. So calcium's over here. Okay, calcium normally has 20 protons, right? And 20 electrons. When we have a positive 2 charge on the calcium, that means calcium has lost 2 electrons. So calcium, the ion, has actually 18 electrons. There's been a loss of electrons from the electron cloud. So the electron cloud of the cation is smaller than the neutral atom. So calcium positive 2, calcium, the ion, is the answer. Now let's take a look at 3 elements and place them in order of increasing size using their ions. Phosphorus on the periodic table is right over here. Sulfur is right next to it, and then chlorine is right next to that. So they're all right next to each other in the same period. So we're being asked to place these ions in order of increasing size. So let's think about what that means. Does that mean largest to smallest or smallest to largest? Increasing size means going from the smallest radius to largest. Okay, now think about how ionic radius changes across a periodic table. When we're moving in a period, within a period, the ionic radius gets bigger. So hopefully you can see that phosphorus would be the largest. But since we're ranking them smallest to largest, you would place chlorine first. So that's your answer for placing them in order of increasing size. It's more important that you know why this is the answer. So let's think about why. Why is chloride ion, why is that the smallest? So let's look at the facts. How many protons and electrons do each of these ions have? If we take phosphorus, phosphorus has 15 protons. Its atomic number is 15. Normally it would have, for the neutral atom, 15 electrons, but because we have a -3 charge here, that means it's gained 3 electrons. So phosphorus, the ion, -3 ion, has 18 electrons. If we look at sulfur next, sulfur is right next to phosphorus. It's got 16 protons, 1 more proton. And because it's got a -2 charge, that means it's gained 2 electrons. So it's going to have 16 plus 2, 18 electrons. Finally, you have chlorine. Chlorine has 17 protons, and chlorine, the atom, has 17 electrons. But because we have a -1 charge here, that means chlorine will have gained an electron to have 18 total electrons. So notice how the electron number is the same for all of these ions. For that reason, we can't use the electrons as our determining factor in figuring out which ion is smaller or which ion is larger. So we need to look at the effective nuclear charge or look at the number of protons. Because chlorine has the larger number of protons, it's going to have the greatest effective nuclear charge. That means it's going to exert the greatest attractive force on those outer electrons, pulling them closer in toward the nucleus, shrinking the size of its ionic radius. So that's why when we're ranking them, chlorine, or the chloride ion, is going to be the smallest. Sulfur's in the middle, and then phosphorus will be the largest. So to sum up, since all of the ions have 18 electrons, we already established that, we will need to look at the effective nuclear charge, the number of protons. we established that the phosphorus ion has 15 protons, the sulfur ion has 16 protons, and the chloride ion has 17 protons. So because chloride has a greater effective nuclear charge, that symbol is ZeFF, than the other anions, it will have the smallest ionic radius.